Right, our third method for solving these equations, or these systems of equations, is going to be solving by elimination. And this happens to be my favorite method, and it works best when you have your x's lined up, your y's lined up, your equal signs lined up, and your constants lined up, when these are in what we call standard form. Something times x plus something times y equals a number. If they're both written like that, then elimination, I think, is usually the way to go. And the way it works is, we're going to want to add these two equations together. We're going to want to add the x's together, add the y's together, add the numbers together, and of course keep the equal sign. So if we do that here, x plus x is 2x. Right? 2y minus 2y is 0. We don't need to write 0. And then 7 minus 5 is 2. Divide both sides by 2, and we get x is equal to 1. All right, we eliminated the y's, and that gave us an equation, a real simple equation with just one variable in it to solve, and that gives us the value of that variable. So we know that the x value in our solution is 1. Now we have to find the y value, and the way we're going to do that is to choose either one of these original equations and replace the x in it with the value 1. So I'm going to choose the top one, just because there's no subtraction in it. I like the looks of it a little bit better. I'm going to replace the x with 1 plus 2y equals 7. That gives me an equation with just y in it that's really easy to solve. Subtract 1 from both sides, divide by 2, and we get y is equal to 3. So the solution, the pair of numbers that works in both of these equations, is 1, 3. Put a 1 in for x and a 3 in for y, you get 1 plus 6, which is 7. Here you get 1 minus 6, which is negative 5. Now this is the easiest possible scenario when you already have numbers in front of x or y that will cause them to go away when you add or subtract. That, of course, isn't always the case, and here's an example where it's not. X plus 3y equals 0, 20x minus 15y equals 75. Well, I want to cancel the y's out here, and the reason I'm choosing the y's is because there's different signs in front, right? If I'm going to have things cancel out, you got to have a positive and a negative. But the numbers don't match. They will, though, if I multiply that top equation by 5. That'll give me 5x plus 15y equals 5 times nothing is still nothing. So I multiply the top equation by 5. Now I've got that situation where if I add these together, I'll get 25x. The 15y and the minus 15y will cancel, and 75 plus 0 is just 75. Divide both sides by 25, and I get x is equal to 3. Okay, so I've got my x value. We just need to go back and find what y is. And here, the first equation is much nicer than the second equation, much smaller numbers. X plus 3y equals 0. So I'm going to replace the x with 3, because that's what I found it to be, plus 3y equals 0. And that's one that I would solve by inspection. I know that the only way that's going to work is if y is negative 1. You want to work it through, that's fine. I apologize. I usually try to get more diversity in the numbers, but we got 1s and 3s in both of these examples. Let's see what happens in the next one. This is our worst case scenario for solving by elimination, and that's where we don't have, well, I chose poorly. That's okay. Let's try to eliminate the y's. We could eliminate the x's if we wanted to by multiplying the top equation by 6 and then adding them together, but I don't want to do it that way. I want to eliminate the y's just to illustrate something. What I want to illustrate is there's nothing nice that we can multiply the top one by to make it be 5y, and there's nothing nice we can multiply the bottom one by to get a 3y. So what we're going to do is multiply both the top and the bottom by something. We're going to multiply the top through by negative 5, because that will give me a 15 in front of y, and then we can multiply the bottom through by 3, and that'll give us a positive 15y. So negative 5 there will give us positive 5x minus 15y equals positive 10. Right? That's what we get from the top one. The bottom one will get 18x plus 15y equals 3 times 34 is 102. So negative 102. When we add these together, we're going to get 23x. The 15y's will cancel. And we'll get 10 minus 102, which is negative 92. And I'm really hoping that 92 is divisible by 23. I'm doing that on the calculator just to be safe. 92 divided by 23 better be 4, and it is 4. Okay, so if we divide both sides by 23 there, we'll get x is equal to negative 4. So that gives us our x value. We need to go back to one of our original equations to find the y value. I'm going to choose the first one just because the numbers are smaller. If we put a negative 4 in for x, the negative of negative 4 is positive 4 plus 3y equals negative 2. Subtract 4 from both sides, we get 3y is equal to negative 6, so y is equal to negative 2. All right, that is the elimination method.